Very well, let's finish chapter 1 by continuing to 1.3, the design of study. Very well, as a statistician, your job is to ask a question, collect the data, visualize the data, analyze the data, and finally make conclusions or inferences about population. So, in the first step, you ask a question. In the second step, you start collecting the data. So I expect you to ask, how do I collect the data? To collect the data, first of all, you have to check to see what type of study are you dealing with. So, what is the type of study? When it comes to statistics, we have two types of study. That study can be either observational or it can be experimental. So observational study are those types of study that you just collect the data by asking questions or posting the questions on a website and randomly collect the data. Randomly collect the data by either asking questions using a website and so on. However, when it comes to experimental study, you have to have a treatment, and after having the treatment for your subjects, you record the data. It involves treatment or treatments for subject, and after the treatment, you collect the data. When it comes to experimental study, you have to be very careful. We have to consider three important factors in experimental studies. The first factor is control. The second factor, randomization. And the last factor is replication. Again, for observational study, you don't have to worry about control, randomization, or replication. The only thing you need to worry about is to collect the data randomly to avoid bias. Let us take a look at two examples. Determine whether the study is an observational study or an experimental study. The first one says, researchers studied the effect of vitamin D3 supplementation among patients with antibody deficiency or frequent respiratory tract infections. To perform the study, 70 patients received 4,000 IU of vitamin D3 daily for a year. Another group of 70 patients received a placebo daily for 1 year. Second one, researchers conduct a study to find the US public approval rating of US president. To perform the study, researchers called 1,500 US residents and asked them whether they approve or disapprove of the job being done by the president. Very well. The second one, as you guess, is just an observational study. They just collect the data without having any treatment. But the first study is an example of an experimental study. There is a treatment, effect of vitamin D3 supplementation, and after the time passed by, for 1 year, they collect the data. So the first one is an example of experimental study. So when it comes to control, you have to control your experimental study. There are some important elements that you have to control. The first element is confounding variable. So confounding variable is a variable that might have an effect in your study without you knowing about it. For example, suppose you have a coffee shop and you say, hey, I'm going to make new decorations. I'm going to, change the color of my coffee shop to attract more customers. At the same time, there is this new mall next to your coffee shop. So people go to the mall and then they come to your coffee shop and you might say, hey, because of the decoration and new color, I have more customers coming to my coffee shop. But you don't know if the new mall has an impact on your coffee shop or not. So the mall is, in this example, a confounding variable. The second element that you have to control is placebo effect. What's the meaning of that? It means that one subject in your experiment, remember vitamin D3 experiment, one subject in the experiment has fake treatment but reacts favorably to the experiment. So you have to control placebo effect as well. So to reduce placebo effect, what we can do, we can use a technique that we call blinding. What's the meaning of that? It means that suppose you have some subjects in your experimental study, you don't let them know that which treatment is fake, which treatment is real. That technique is called blinding. This actually helps to reduce the impact of placebo effect in your study, in your experimental study. So we talked about control. Now randomization, of course. Randomization is very important to avoid any bias, either in an observational study or in an experimental study. It's very important to have randomization so to avoid bias. And finally, replication. You need to be able to replicate your experimental study to be able to repeat and replicate all the steps. Let's take a look at one example. Example 2. Analyzing an experimental design, a company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with the given experimental design and suggest a way to improve it. The first one, the company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and the other 5 subjects are given a placebo. After 2 months, the subjects are evaluated, and it is found that the 5 subjects using the new gum have quit smoking. 2, the company identifies 1,000 adults who are heavy smokers. As you can see, we increase the number from 10 to 1,000, which is a good thing. The subjects are divided into blocks according to gender. Females are given the new gum and males are given the placebo. After 2 months, a significant number of female subjects have quit smoking. What's wrong with the first study? First of all, the size, the number of people in your sample is not very good. It's just 10 people. So we prefer to have more people in our sample. This is the very first problem. The second one, it doesn't say anything about randomly selected. So there are 2 problems in the first case. The first one is that there are not enough people in your sample, and the second one, it must be randomly divided into 2 groups of 5 people. How about the second one? In the second one, okay, we have enough people, 1,000 adults, okay, that's a good thing. But what makes it a study that there's something wrong here is they are dividing these into 2 groups of males and females. It must be randomly selected. Randomization is very important to avoid any bias in your study. We are on page 5. Very well. We talked about census, population. A census is collection or information or data of every single person, every single number from the population. Of each entire measurements or data from a population. So as you remember, population is very big. You take a small sample sub-collection and you have a random sample. Random, or just a sample, is a sub-collection or a portion of your population. So note that since you're taking a small portion of your population, the result of the sample might be slightly different from the population. So note that we have sampling error, which is the difference between population result and the sample. For example, you want to know what's the mean or average housing prices in California. Then you take a sample, small sample in the Bay Area, and you say that, hey, this is the average that I have. So the average for Bay Area must be the same as the average for California itself, but in reality, it's not the same. So we have sampling error. Now, when it comes to sampling, we can apply many methods, different methods. I'm going to mention 3 methods here for you. The first one is stratified sampling. Sampling methods. The first one is stratified sampling. In this method, you as a statistician come up with ideas to categorize your population and take random samples from that population. So, for example, a stratified sample can be for categorizing, for example, a population into different socioeconomic groups. Group 1, low income, middle income, high income. Then randomly select people or family from each of these stratified sampling. The second one is called cluster sampling. In a cluster sampling, as a statistician, you look for natural ways to categorize the population, then take random samples. For example, a cluster sample can be of the form. So you have your population. It's naturally divided into different zones, zip codes. Zone 1, Zone 2, Zone 3, and so on. So you just take a look at different zip codes and you randomly select the people or family from that population. And finally, the third one is called systematic sampling. So let me write this here for you. The third one, systematic sampling. In this case, you take each member from the population. So you have to have the population. You assign one number to each person in that population. Then, as a statistician, you randomly select those numbers. This is called systematic sampling. Let us take a look at one example. Identify sampling techniques. You are doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling technique you are using when you select the samples listed. Discuss potential sources of bias, if any. The first one, you divide the student population with respect to majors and randomly select and question some students in each major. 2, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. And finally, you select students who are in your biology class. Very well. As you guessed, the first one is an example of stratified sample. You decide to divide students into majors. Then you randomly select from those majors and ask questions. For the second one, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. So this is one of the examples of systematic sampling or just a random sample. 3, okay. You decide to just ask students who are in your biology class. If you think about it, it's very convenient for you as a statistician to, instead of going to campus and asking random students, to select students who are sitting next to you in your biology class. This is a bias. In this case, we say that we have convenience sampling, which is bias. As a statistician, you have to avoid convenience sampling.